Okay, this is Mr. Ross from Parkview High School, and this lesson is about reviewing how to graph exponential functions. So just a quick review of the basics of it all. An exponential function is of this form, where you have a in front that tells you whether it's a stretch or a compression. All right, so a tells you if the graph is stretched, compressed, or reflects over the x-axis, meaning that instead of going upwards, it goes downwards, as in reflects over the x-axis. The b value tells you whether it's growth or decay. So if that's bigger than 1, that's exponential growth. If that's in between 0 and 1, like 0.5, 0.3, 0.75, any fraction or any number like even 1/2 or 3/4, any number between 0 and 1, it's decay. So just to be clear, it's growth if b is greater than 1. It is decay if b is in between 0 and 1. This letter here, H, tells you whether you shift left or right. It basically does the opposite of what the sign says. If it says subtraction here, it goes to the right that many units, whatever H is. If it says plus here, it goes to the left that many units. So it does the opposite of that sign. And K is shift up or down, or your horizontal asymptote. So K tells you horizontal asymptote, and it also tells you whether it goes up or down. Unlike H, it does exactly as it says. Plus means it went up, subtraction means it goes down. And that's the basics of it all. Let's actually apply it now. Alright, so it says graph each of these functions without a calculator, and then state the asymptote. So if we're going to begin graphing this, I will first decide the easy part first. And that's my horizontal asymptote. This one I can clearly see is -4. If there's no number being added to the end, like if it ended right here, that means your horizontal asymptote is 0, because it's plus 0 being added to the end. So the number horizontal asymptote is -4. I'm going to go down 1, 2, 3, 4. I'm going to draw a horizontal line, and this is a line my graph would not cross. We'll just approach it, but this is like a wall that graph won't actually cross. From there, though, I need points to finish graphing it. The best way of coming up with 2 points is this. If b is greater than 1, use a table and let x be 0 and 1. If b is in between 0 and 1, let's just say less than 1, because you won't get a b value that's negative. But if b is in between 0 and 1, you want to use the x and y table. But instead of using 0 and 1, you will use 0 and -1 as your 2 inputs for x to come up with the rest of the graph. So now that I know my horizontal asymptote, in this problem, b is 3. So since it's bigger than 1, I'm going to use 0 and 1. So I'm going to plug in 0 into that equation and plug in 1 into that equation. I'm going to need more space than that. So let's use this page. I'll plug in 0 into that equation. It should be 2 to the 0, take away 1, take away 4. So that's 2 times 3 to the -1, take away 4. And you can plug that into your calculator. So 2 parentheses 3 raised to the -1, and then subtract 4. It gives you -3.3 repeating. So the output is -3.3 repeating. Let's be sure to put that in the table. So the input is 0, output is -3.3 repeating. Then I need to input 1. So taking that same equation, which was 2, then parentheses 3 raised to the x, take away 1, take away 4. I'll plug in 1 for x. I can plug that into my calculator. This is actually pretty easy. 1 take away 1 is 0. So 2, 3 to the 0, take away 4. So I'm plugging 2, parentheses 3, raised to the 0, take away 4, and gives you -2. So output's -2. Alright, so make note of that in my table. And my input was 1, my output was -2. Once you have your horizontal asymptote and 2 points, you can graph it. So what you need first is your horizontal asymptote and 2 points. So now to have that, 1 point was 0 and negative 3.3, so it's about 1, 2, 3, and it's roughly here. And then 1, negative 2, so it's here. I'm going to connect those dots going upwards. And then we'll connect these dots where it looks like it asymptotes there. I don't actually go through that line. I just make it become that line, which was negative 4. So I've graphed it. And that's it. So what you want to first is, find a horizontal asymptote. And then second, find 2 points using either 0, 1 or 0, negative 1. And then third, graph it all. So let's get started here. So our first step, we find a horizontal asymptote. So here, my horizontal asymptote is 2. So my first thing, we'll plot a line at 2. So 1, 2. I've now graphed my horizontal asymptote, which is the easiest thing to do. And then I need 2, because that number, the b value is less than 1. I chose 0 and negative 1 as my inputs. So I'm going to find outputs for those two numbers. So taking that equation, which was negative 10, then 0.5, raised to the x, take away 1, take plus 2. So I'm first plug in 0. So 0 take away 1 plus 2. So it gives you negative 10.5 to the negative 1 plus 2. And that output is negative 18. Which is a really big number. But at 0, the output's at negative 18. And then at negative 1 is my next one I'm going to choose. So taking that same equation, plugging in negative 1. So it's going to be negative 10.5 to negative 1, take away 1, plus 2. And you plug in, that's a negative 2. So it's negative 10 to the point times 0.5 to the negative 2 plus 2. And output's negative 38. My graph I have is not big enough to actually graph that. But I'm going to write this down as negative 38. And because that's not enough space, I'm going to draw my own graph for it. I know I have a horizontal asymptote at 2. So here's 2. And then I have a coordinate of 0, negative 18. So 0, I'm going to just mark this to be negative 18. Way down there. That's a point. Another point is at negative 1, negative 38. So at negative 1, output's twice as far down. So I make it look like it's twice as far down. Call it negative 38. So I have 2 points. I want to make them approach that asymptote like that. And I've now graphed it. That was a really big graph, so I had to make my own. Let's do a different one. All right, so now you're going to try these. Now, before you begin, though, I just noticed that this is written with the negative sign here. So before you begin, I would suggest you do this. Unless this is written in parentheses, you should assume that negative sign is not connected to the 2 in as b. So that negative sign really tells you what the a value is. This is really negative 1, then parentheses 2, raised to the x plus 3, plus 6. So that if there's a negative sign like this, that means that your a value is negative 1. So right now, you can actually graph it if you actually follow the steps. Decide the horizontal asymptote, and then decide whether or not you choose 0 and 1 or 0 and negative 1 to graph the line. So do that now. All right, so long story short, you should have found that you had a horizontal asymptote of 6. The 2 points were 0, negative 2, and then 1, negative 10. And you should have graphed the points and then drew the graph. Just a quick review though. we should have recognized this goes left 3 because it says plus 3 here, and that's a transformation happening here. We should also see that it goes up 6 because it says plus 6. We should also recognize that because that's negative 1, we see that that tells you it's a reflection. Reflection over its asymptote, or you might say x-axis. Reflection over its asymptote, or better yet, just the x-axis. So that's how that graph can transform. That's the last one I'll give you just like that one. So got one last thing to mention that deals with coming up with an equation by looking at the graph.